x-axis, this is y-axis, and this is origin of the coordinate axis. Suppose 2 points are chosen, P here and Q here, and coordinate of this point is x1, y1, and Q is x2, y2. And we have to find some point in between P and Q, joining the line segment, that is PQ. It divides, suppose R is the point that divides this line segment in the ratio of m is to n, right? It means what? That is PR upon RQ is equal to m by n. We will draw perpendicular from here on x-axis. From here also it is on this. This is also dropped. Perpendicular on x-axis means this is 90 degree. Right? Similarly, from this point we will draw perpendicular on, suppose it is P1, this is R1, right? That is Q1. From here if you draw perpendicular on this, and from here on this, right? Suppose it is S and this is T, right? So this is also 90 degree. This is perpendicular dropped on this. Okay? So both the triangles are right angle triangle, right? Triangle PRS and QRT both are right angle triangles. This is parallel to this, isn't it? And this is transversal. So this angle will be equal to this angle. This is 90. Naturally, this angle will be equal to this angle. So considering these two triangles, right? So from triangle PRS and triangle RQT and RQT, these two triangles, angle this, that is RPS, angle RPS is equal to angle QRT, and angle RSP, angle RSP is equal to angle QTR, each 90 degree. Two angles are equal. Then also triangles will be similar because third angle will automatically be equal. Therefore, triangle PRS is similar to triangle RQT, isn't it? So when two triangles are similar, in the chapter of triangle I have taught you, when the similarity of two triangles are there, then the ratio of the corresponding sides are also equal. In these two triangles, which are the corresponding sides? You see, PR, this side lies between this angle and this angle. So the corresponding angles are this and this. Therefore, PR upon RQ, ratio of the corresponding side. This side corresponds to this. This side corresponds to this side. So PS upon RT. So you will write PS upon RT. Right? Similar the last one, that is RS upon QT. RS upon QT. You are getting now? Corresponding sides you have to look at. इस ट्रायंगल का और इस ट्रायंगल का corresponding sides क्या होगा? So you see single line angle, double line angle, single line angle, double line angle. So this side, right, is in between these two angles. Similarly, corresponding angles are these two. So this side RQ lies between these two angles. So these are the corresponding sides. That is why I have written PR upon RQ. Similarly, this side, right, 90 degree angle, single line angle, 90 degree and single line angle. So these two sides are corresponding sides. So the PS upon RT. Similarly, the remaining side, this will also. So this relation, it is very important. Now, let this be a first equation. Right? Then we will proceed further. See, coordinate of this is xy. Coordinate of this is x1, y1 means this is x1, right? From here to here it is x, and from this origin to this, right, this is x2. From here to here it is x2. So this part will be x minus x1, this will be x minus x1. Similarly, this part will be how much? x2 minus x, that is x2 minus x, isn't it? This P1 R1 is x minus x1, R1 Q1 is x2 minus x. So this is parallel to this, this is parallel to this, so this will also be x minus x1 and this will be x2 minus x. Clear? Similarly, if you look at this is complete is y. From R1 this is y coordinate, and P1 it is y1, and from here to here it is y completely. So this will be how much? It will be y minus y1, this part. Similarly, this part will be how much? y2 minus y. So we have got some relation in sides also. Now we will look at with this relation and these sides, we will find some conclusion. We have to find x and y. So see, PR upon RQ. So this we can write, or PR upon RQ. I will make two relations. This is equal to this and this is equal to this. So PR upon RQ is equal to PS upon RT. This is the second relation I will make, and PR upon RQ, that is equal to RS upon QT. This is third relation I made. Right? So from equation 2, PR upon RQ. What is PR? PR is M, RQ is N. So therefore M by N I will write. PR upon RQ is M by N. PS upon RT. What is PS? PS is this, that is x minus x1, and RT is this, that is x2 minus x. x2 minus x. Therefore, by cross multiplication, we will get M x2 minus x is equal to N x minus x1. Now we will simplify this. Therefore, mx2 minus mx is equal to nx minus nx1. So I will take this side and all x on other side. Therefore, mx2 plus nx1, that is equal to mx plus nx. So here we will take x common. Therefore, mx2 plus nx1 is equal to x common m plus n, or x is equal to mx2 plus nx1 on m plus n. This x coordinate we got. In the similar fashion, using 3 we can find the y coordinate. For y coordinate, this relation we will take. So we will write from 3, that is PR upon RQ, that is equal to RS upon QT. Put the values. PR upon RQ, the PR upon RQ, that is M by N, that is M by N is equal to RS. What is RS? This part. This part is y minus y1. So y minus y1 upon QT. This QT. QT is y2 minus y. So y2 minus y. Further simplification, by cross multiplication we will go. We will get therefore m y2 minus y1 is equal to n y minus y1. Right? Again simplification in a similar manner. Therefore m y2 minus m, it is not y1, it is y. Right? My is equal to n y minus n y1. Next, therefore, my2 plus ny1 is equal to my plus ny. Therefore, my2 plus ny1 is equal to y common m plus n. So I will write therefore y is equal to my2 plus ny1 upon m plus n. So these two formulae we got this one and this one. So this way, with this formula we can find the coordinate of the point on the line segment which divides it in the ratio of m is to n. Clear? So question arises how to remember. See, my2 plus ny1 upon m plus n. See, this point, m is there with this point, n is there with this point. So m will be multiplied over here and n will be multiplied over here. This way you have to remember. M y2 n y1 upon n plus 1. M x2 n x1 upon m plus n. This is the way how can we remember, right? X is this, y is this. Some special cases I will talk about. So special cases. Special case. What is the special case? Suppose 2 points are given. I want the midpoint. What is the coordinate of the midpoint? Suppose this is the point P. This is the point Q. Coordinate of this is x1, y1. Coordinate of this is x2, y2. It is joined and this is the midpoint, right? R, that is x on y. So since it is a midpoint, it divides the line segment in equal ratio, right? Equal ratio in the sense it is length will be same. PR is equal to QR. It is a midpoint. R is the midpoint. Therefore, PR is equal to QR. Isn't it? So what the ratio of these two? Therefore, PR upon QR is equal to 1. So ratio is 1, means 1 is to 1. So it is 1, it is 1. This m is 1, n is 1. In this formula, if you use, then we will 1 is to 1, that is m is this, n is this. So if you are finding the coordinate of midpoint, so you will write therefore x is equal to what? M is 1, n is 1. So 1 into x2 plus 1 into x1 upon 1 plus 1. M plus n is 1 plus 1, that is 1 plus 1, that is 2. So this is equal to x2 plus x1 by 2, or we can write x is equal to x1 plus x2 by 2. Similarly, y is equal to y1 plus y2 by 2. So this is the formula for midpoint, right? This is the midpoint. Midpoint. So this is called midpoint formula. It is called midpoint formula. One question I am taking, P is equal to 3, 7, right? This is the point. And Q is equal to minus 3 and 5, right? Then find the point between P and Q which divides it in the ratio of 1 is to 2. We have to find one point which divides this in the ratio of 1 is to 2. So for understanding, suppose this is a point P, this is Q, that is P, that is 3, 7, this is Q, it is minus 3, 5. Suppose 2 points are there and it is dividing 1 by 1 point, it is being divided by 1 point, that is R, that is X, Y in the ratio of 1 is to 2. See, according to formula, if you are writing X coordinate of this we have to find. Means 1 is to be multiplied by this, 2 is to multiplied by this, divided by 1 plus 2. As I told you, how to do? m is to m is this. If since m is here in this side, right, m इधर में है, तो इस पार्ट में जो m है तो m को इससे मल्टीप्लाई करें, इस पार्ट में n है, n को इससे मल्टीप्लाई करें, डिवाइड बाई m प्लस। सी कैसे करेंगे, 1 मल्टीप्लाइड बाई -3, 1 इंटू -3 प्लस 2 इंटू 3 डिवाइडेड बाई m प्लस n, दैट इज 1 प्लस 2। अब इसको सॉल्व करेंगे, क्या आ जाएगा, दैट इज -3 प्लस 6 अपॉन 3, दैट इज हाउ मच, 3 by 3, that is 1. X coordinate 1 again. I will talk about y coordinate. Again 1 into 5 plus 2 into 7 upon 1 plus 2. How much it is? 5 plus 14 by 3, that is 19 by 3. Therefore R is how much? 119 by 3. This is the coordinate of the point in between P and Q, which divides this line segment PQ in the ratio of 1:2. If I want the coordinate of midpoint of this line segment, so midpoint, coordinate of midpoint if you want, दूसरा midpoint का जो coordinate होता है, तो उसका कोऑर्डिनेट सपोज हम बोलते हैं x3 y3, it is the midpoint. So what is the value of x3? So x3 will be equal to, as I told you, formula is there, sum of these two coordinates, x coordinate and y coordinate, divided by 2, isn't it? So x1 is this, that is 3 plus x2 is this, that is -3 divided by 2, that is 0 by 2, that is equal to 0. Means midpoint x coordinate is 0. Now we will talk about y coordinate. So that will be y3. So y is this plus this by 2, isn't it? y1 plus y2 by 2, that is 7 plus 5 by 2, that is 12 by 2, that is equal to 6. Therefore, what is the coordinate of midpoint? So therefore x3 y3 is equal to 0 and 6. This is the coordinate of midpoint, and this is the point which divides this line segment into 1:2.